Let's look at transfer learning and how we can easily use PyTorch to pull in a neural network that's already trained to classify certain images for us. Here's we're running this in Colab. This is just the preliminary data that we have set up. We are going to be using an ImageNet trained neural network in this particular one, although there's others that you can certainly use. We're going to use a height and width of 224. So we're going to force the images into that size, and then we are going to classify on those. We're loading ResNet 50, which is a good neural network for this sort of thing. We are loading the weights. You can also just get the structure of ResNet 50. And that can be very useful. We'll see that more when we get to the Kaggle competition. But you can take the structure of these complicated neural networks and then train it so you don't have to figure out your own system of max pooling layers and convolution layers, which can be a very challenging endeavor. I describe sort of the code that is used there. We are going to do a pre-processing pipeline for each of the images. We're going to resize them to 256, center and crop them at the image width, and convert them back to tensors, and so they can feed into the neural network. And we're using our usual normalization across the red, green, and blue values to move them to within 0 to 1 and standardize the distribution of those values. We are going to download from this file here. This contains of the 1,000 images that this thing is capable of classifying. It has the names of what each of those 1,000 images are. Then we create a function that is going to classify images that we actually pass into it. So we definitely switch into evaluation mode. We are going to download from the URL that we were given, and we're going to resize it to the width and height that we specified above. We're going to display the image just so that we can see it. And then we're going to convert it into tensors using the pre-processing pipeline. This is the form that PyTorch requires so that we can actually pass it into the PyTorch neural network. We're going to run PyTorch with no gradients because we're not training. That makes it faster. And then we call the model. We take that image tensor that we got from the pre-processing steps, and we look at the outputs. The outputs are going to be your probabilities, 1,000 of them across those 1,000 ImageNet classes. And then we're going to print out those probabilities and print out what image from those 1,000 images that we loaded corresponds. So we're going to look at a couple of images here. We're going to look at the soccer ball and a racing truck. Normally you think of a truck or a race car, but this one's both. So I thought that would be fun. Here's a soccer ball. You can see it's pretty sure, 90% probability that it is in fact a soccer ball. I can see where a guy might get confused and think it's a honeycomb. No idea where it would think that's a whistle, but these are below 1%. So not too much of a probability there. Predicting it as a racer or a race car, a sports car maybe, but there's a steep drop off. It's about 80% sure that it's a race car of some sort. And this is how you can use these pre-trained models to either use as a starting point for your own training or off the shelf ready to classify some images. These classify images sort of one at a time. We'll also see that you can do multiple image classification using YOLO. Thank you for watching the video, and if this is useful, please click the like button or subscribe to the channel so you get the future videos that I add to this course, as well as machine learning projects that I do.